Welcome to the DIY Honda Garage channel. The diagnostic trouble code, DTC P2651, signifies a problem with the rocker arm oil pressure in a Honda CR-V 2023 or newer model. The error indicates that the rocker arm oil pressure sensor output remains low when the rocker arm oil control solenoid is activated. Essentially, the engine's powertrain control module, PCM, recognizes this anomaly, suggesting possible issues within the VTEC, variable valve timing and lift electronic control system. This system is crucial in optimizing engine performance and efficiency by adjusting the timing and lift of the engine's valves based on driving conditions. Located within the engine, the rocker arm oil pressure sensor and rocker arm oil control valve play critical roles in maintaining proper oil pressure for effective valve operation. A visual inspection of these components is a primary step in diagnosing the issue accurately. In summary, when encountering DTC P2651, a comprehensive understanding of these components, along with their functions in controlling engine performance, is vital for effective troubleshooting. In the Honda CR-V, the rocker arm oil pressure sensor measures the oil pressure used to control the rocker arms. This sensor is located on the rocker arm oil control valve, situated near the engine's valve cover. The primary role of this sensor is to provide feedback to the PCM about the oil pressure status, which is crucial for the operation of the VTEC system. If the recorded oil pressure is low, the PCM may interpret this as a fault condition and store the DTC P2651. The rocker arm oil control valve manages the flow of oil to the rocker arms, impacting how well the engine performs, especially during variations in speed and load. This entire assembly is integral to the engine's performance, and accurate pressure readings are necessary for efficient engine operation. The potential causes of DTC P2651 can lead to significant engine performance issues. Firstly, a faulty rocker arm oil pressure sensor might not accurately measure oil pressure, resulting in low output readings to the PCM. Secondly, if there are clogs or debris within the VTEC system oil passage, it can disrupt the oil flow necessary for the rocker arms, preventing them from operating effectively. This could cause the engine to not perform optimally and trigger error codes. Lastly, a defective rocker arm oil control valve can fail to manage oil flow adequately, leading to insufficient pressure and activating the warning code. Proper inspection of these components is essential to ascertain the root cause of the problem and actionable solutions. When dealing with DTC P2651, several symptoms typically manifest that can impact the overall driving experience. One common symptom is a noticeable reduction in engine performance, which may include sluggish acceleration and poor engine responsiveness. Additionally, you may encounter an increased oil pressure warning on the dashboard, indicating potential engine lubrication issues. This warning signals that the oil system is not functioning as it should, which could lead to more significant engine problems if left unaddressed. Lastly, the engine warning light will likely be illuminated on the instrument panel, serving as a clear indication to the driver that immediate attention is required to troubleshoot the issue effectively. The first step in troubleshooting DTC P2651 involves starting the engine and holding the engine speed at 3,000 revolutions per minute, RPM, without any load, which means the vehicle should be in park, P, or neutral, N. This elevated RPM is maintained until the radiator fan activates, indicating that the engine is reaching operating temperature and that sufficient oil pressure is building in the system. The next action is to let the engine idle to observe any changes in the pressure readings. Following this procedure, performing the Honda Diagnostic System, HDS, VTEC test is crucial. This test assesses the functionality of the VTEC system and ultimately helps determine if the rocker arm oil pressure sensor is working properly. Gathering this data is vital for the next steps in isolating and rectifying the issue. In this troubleshooting step, begin by disconnecting the connector from the rocker arm oil pressure sensor, which has a 3-pin 3P configuration. This action interrupts the electrical signal sent to the PCM, allowing for a physically isolate inspection. Next, the sensor needs to be carefully removed from the rocker arm oil control valve, a critical component in regulating oil pressure. At this stage, you will attach an oil pressure hose along with the required pressure gauge adapter and other tools to measure the oil pressure accurately. The specific torque settings for reattaching the sensor to the oil pressure gauge adapter are important to maintain proper connections and ensure the accuracy of the pressure readings. Following these configurations, you will then reconnect the rocker arm oil pressure sensor connector for the next phase of testing. To ensure all previous steps yielded valid results, you must conduct a confirmation procedure post-installation of the oil pressure measurement setup. During this time, it's crucial to observe the oil pressure readings displayed on your HDS. If functioning correctly, the oil pressure should exceed 49 kilopascals, kPa, which is equivalent to 0.50 kilograms per centimeter squared, kgf, cm squared, or 7.1 psi, simultaneously confirming that the VTEC solenoid valve is in the on position. This confirmation shows that proper oil pressure is being generated and is an essential benchmark for diagnosing the next steps. If the pressure meets these requirements, the issue is likely with the rocker arm oil pressure sensor itself. Conversely, if the readings remain low or abnormal, more extensive evaluations of related components are warranted. In this step, the focus shifts to inspecting the VTEC system oil passage, as obstructions can severely impede oil flow necessary for proper engine operation. To start, check for any debris or clogs, which can be potential sources of low oil pressure and are indicative of maintenance neglect. Thorough inspections can ensure that these passages are clear, allowing for adequate oil flow through the VTEC system. Normal conditions dictate that there should be no obstructions present in the passageways, ensuring efficient oil delivery. If debris or clogs are found, this would point toward a blockage in the system, necessitating cleaning procedures or component replacements to restore functionality. Conducting this analysis is paramount for ensuring the integrity of the engine's lubrication system, integrating seamlessly with the rocker arm oil control valve's functionality. If prior inspections confirm the normal conditions of both the rocker arm oil pressure sensor and VTEC system oil passages, attention should then turn to the rocker arm oil control valve itself. This step is critical as this valve is pivotal in managing the oil flow that feeds the rocker arms. Conducting a thorough inspection will help identify any faults or blockages that may be causing inadequate oil pressure readings. If the other components are functioning correctly and the issue remains, it can be concluded that the rocker arm oil control valve is likely defective. Its failure could lead to inconsistent or insufficient oil supply, adversely affecting engine performance. It is essential to address this potential issue promptly to avoid further engine complications. After performing the necessary repairs or replacements based on the diagnostic process, the final repair verification stage is essential to ensure that the solution implemented has resolved the issue. First, you need to confirm that all components involved, namely the rocker arm oil pressure sensor, VTEC system oil passage, and rocker arm oil control valve are functioning as intended. Following this, Check the diagnostic system again for any additional DTCs to affirm comprehensive corrections have been made. Finally, clear the stored DTC and conduct a test drive to monitor performance. Observing the vehicle under normal operating conditions helps ascertain whether the repairs have been effective, ensuring that the rocker arm oil pressure is operating correctly without triggering further warning codes. This step is vital to restoring vehicle functionality and ensuring lasting repairs. Preventive maintenance plays a crucial role in maintaining the optimal performance of the Honda CR-V and can help prevent issues related to DTC P2651 from arising in the first place. One fundamental procedure is to conduct regular oil changes, which not only refreshes the oil, but also removes contaminants that can lead to blockages in the VTEC system. Keeping an eye on engine oil levels is equally essential, as insufficient oil can significantly impair the effectiveness of the rocker arm oil control valve and other components. Additionally, periodic inspection of the VTEC system ensures that all passages remain unclogged and functioning properly, extending the lifespan of critical engine components. By adhering to a well-structured maintenance schedule, you can enhance engine performance and efficiency while mitigating the risks of encountering DTC P2651. In summary, troubleshooting DTC P2651 involves an understanding of the rocker arm functionality and the implications of a stuck oil pressure reading. Focusing on the systematic method of diagnostics, starting from basic engine checks to specific component inspections, provides a structured way to identify problems. Recognizing the roles of the rocker arm oil pressure sensor, rocker arm oil control valve, and VTEC system oil passage ensures thorough evaluations, leading to informed repairs. Emphasizing the importance of regular maintenance practices further reinforces the vehicle's health, reducing the chances of future occurrences of DTC P2651. By following these outlined steps and preventive measures, Honda CR-V owners can uphold their vehicle's performance and enjoy a reliable driving experience. Please like and subscribe to the channel. See you next time.